Today we're starting Chapter 16, Probability in the Binomial Theorem. So we're on page 1 of our Chapter 16 notes packet. And the first section of this chapter talks about the counting principle. And the counting principle is this. If one activity can occur in any of m ways, and following this a second activity can occur in any of n ways, then both activities can occur in the order given by m times n. So you would multiply m times n. For example, there are 2 entrances to a building and 4 stairways to the second floor. So let me just quickly sketch a building. All right. Suppose we have this building as a front entrance and a side entrance. And then there are 4 stairways to the second floor. So 1, 2, 3, 4. How many different ways can a person enter the building and reach the second floor? Well, again, there were 2 ways to enter and then 4 ways to reach the second floor. So we multiply 2 times 4, which results in 8. Another example, there are 10 girls and 11 boys in a math class. And how many ways can a boy and a girl be selected to represent the class? Well, we need a boy and a girl. We need a boy and a girl. Well, how many boys are there to choose from to select? 11. And then there are 10 girls. So 11 times 10, which is 110. Oftentimes I'll use these kind of helpers, which I call slots. The next example, 12 runners are in a race, and how many different ways can first place, second place, and third place medals be awarded? All right, so we're looking for first place, second place, and third place. Well, there are 12 runners. Now for first place, any one of those 12 runners could make first place. For second place, now there's a runner in first that's already taken first place, so how many runners remain to place second? 1 less than 12, 11. And now first and second place have been taken up, so now there's only 10 runners that remain to be placed in third. So we would multiply 12 times 11 times 10. 12 times 11 is 132 times 10, 1,320. And our last example, 5 people one at a time walk into a classroom with 9 empty seats. And how many different ways can the people sit in the seats? Okay, we've got 9 empty seats. 1, 2, 3, 4, 5, 6, 7, 8, 9. We only have 5 people, so one at a time they come in and sit down and sit in a seat. So first person comes in, takes a seat. That's 5. It's got 9 seats to choose from. That's for our first person. Then our second person comes in. How many seats does he or she have to choose from? 8. Only 8 seats that remain. Third person comes in, has 7 seats to choose from. Fourth person, now 6. And the fifth person now has 5 seats to choose from. That takes care of all of our 5 people, okay? So we multiply 9 times 8 times 7 times 6 times 5. And this is equal to, take out the calculator, 15,120. Right? So even though I didn't fill all my slots, Okay, it gave me the thinking of, okay, if there's 9 seats there, then that first person walks in, they've got 9 seats to choose from. So really, I might have been better off just drawing the 5 slots to begin with. Right? First person has 9 seats to choose from, second person walks in 8, third person 7, fourth 6, and then the fifth 5 seats to choose from. Okay, so that's the counting principle. Now, permutations and combinations. I want to have the calculator for some of these. A permutation is an arrangement of objects in a specific order. So whenever you have permutation, okay, order matters. For example, the arrangement of the numbers 1, 2, and 3 can be, we can have 1, 2, 3, 1, 3, 2, 2, 3, 1, 2, 1, 3, 3, 1, 2, or 3, 2, 1. So that's a total of 6 different arrangements. It's 6 different arrangements. The notation, the number of permutations of n objects taken r at a time, is NPR. On the calculator, we use the math button. Okay, so if I want to key in 4P4, we enter math, and then we have to go over the probability. Let's see if I can get this in here. So I just hit the math key beneath the green alpha key, and now probability is here. So I can right arrow over to it, or I can just left arrow once and it'll bring me there. And NPR is 2. So I go down to 2. Right. I must have had something in the calculator already. Let me clear that out. Try again. So I want 4 math NPR. I'm sorry, PRB, now NPR. 4. It's 24, which is the same as if I take 4 and math probability factorial, that exclamation point in mathematics, number 4 there, is factorial symbol. That means 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1, which is 24. 7P3, right? If I work it out on the calculator, 7 math probability NPR, that's 210. And what this means is we start with, there's another way of working this out by hand. All right, that would equal 210 on the calculator. By hand, you start with the number 7, and you want 3 positions to follow. So I'm going to do 7, and then 6 and 5, and you multiply them. 7 times 6 times 5, well, 6 times 5 is 30, times 7 is 210. Sometimes, I don't know, again, I find the calculator rather cumbersome to use, to type in all the keys. It takes me longer to type it into the calculator than to work it out by hand at times. So 10P2 would mean we want just 2 numbers. Start with 10 and decrease by 1, so 10 and 9. So 10 times 9, which is 90. All right, you can check it on the calculator. Okay, in 10, probability. Oh, I forgot the 2. See that? Always mess up on the calculator. All right, so I get that back, and now if I put in the 2, 90. For example, how many ways can 4 friends stand in a line to purchase movie tickets? All right. well, there's 4 friends. They're going to form a line of 4. So we can think of this as different arrangements of 4 from 4. All right, arrangements of 4. So 4p4, which is the 24. Or 4, 3, 2, 1. The second example, how many ways can the letters of the word pencil be arranged? Well, how many letters are there? There's 1, 2, 3, 4, 5, 6. Right? So this would be 6-letter arrangements taking 6 at a time. 6p6, go to the calculator, or 6 times 5 times 4 times 3 times 2 times 1, which is 720. How many ways can letters of the word pencil be arranged if the first letter must be a vowel? Okay, so now we have a special condition. The first letter must be a vowel. So out of my 6 letters, draw 6 dots. The first one must be a vowel. Well, how many vowels are there to choose from to place? There's the E and the I, so there's 2. All right. Now a vowel has been placed, now fill in the rest of the slots. How many letters remain? 5 and 4, 3, 2, 1. And multiply these. It's 240. The next example, how many ways can 4 out of the 6 letters of pencil be arranged? Okay, so now we don't want all 6, but only 4 out of 6. So we want 4-letter arrangements, so 4 slots. How many letters are there to choose from to place in the first slot? Well, there's 6. One's been placed, now 5 remain. Now 4 remain, and 3. So 6 times 5 times 4 times 3, which is 360, which can be the same written as from the 6, we want arrangements of 4, 6p4, which would result in 360. On to page 2. The number of permutations of n things taken n at a time when r are identical is n factorial divided by r factorial. So n is the total number, and r is the number of times something repeats. So this is the number of repeats, or the number of times something repeats. So how many different arrangements of the word freeze are possible? Okay, well, freeze has 1, 2, 3, 4, 5, 6 letters, so that would be 6 factorial over 1, 2, 3. The E repeats 3 times, so this would be divided by 3 factorial. And we'll have to go to the calculator for this. All right, for factorial. See if I get this in the right way. Okay, so 6 factorial, math, probability, factorial is 4, divided by 3 factorial. Is 120. There's 120 different possible arrangements in the letters of the word freeze. Next, try roller coaster. Count how many letters? 13, so that'd be 13 factorial divided by, let's see, we have 1, 2, 3 R's, so 3 factorial for the R's, 1, 2 O's, 2 factorial for the O's. We have 2 L's, another 2 factorial for the L's, and 2 E's, so 2 factorial for the E's. All right, now we put this in the calculator. Let's use the fraction key. Alpha y equals 13 factorial, 13 math probability over 4, okay, divided by 3 factorial times 2 factorial. Now 2 factorial is simply 2 times 1. So we know that's going to be 2, but so I'm going to save myself typing in the factorial. All right, 2 factorial is 2 times 1. So this is simply going to be 3 factorial times 2 times another 2 for the second 2 factorial, and then times another 2 for the third 2 factorial. And we have this large number. And yes, it's correct. So let's see. We've got 600, 729,000, so 129,729,600. So this is equal to 129,729,600. Large numbers. We're going to come up with some rather large numbers here for some of our answers. Kingston. Kingston has 8 letters, so that would be 8 factorial divided by, does anything repeat? Yes, has 2 n's, divided by 2 factorial for the n's. 8 factorial divided by 2 factorial. I'm going to save the time putting into the calculator and tell you that it comes out to be 20,160. Just 8 factorial divided by 2. Calculator. How many different arrangements of the word calculator? Well, calculator, that's 3, 3, 3, and 1. That's 10 factorial, 10 letters. So 10 factorial divided by, let's see, the number of times something repeats. So we have 2 C's, 2 factorial for the C's, and then 2 A's times another 2 factorial for the A's. And we also have 2 L's. 10 factorial divided by 2 times 2 times 2 would result in 453,600. All right, and the last thing we're going to look at is combinations. A combination is a selection in which order is not important. So order doesn't matter here. For example, if you take a committee of 3 people that has John, Ann, and Lee on it, the order in which they are grouped doesn't matter. They all just make one group. All right. The following would be all the same committee: John, Ann, Lee, Lee, Ann, John, Lee, John, and Ann, Lon, and John. Sorry, and Ann, John, and Lee. All right. They're all the same group of 3 people. Order does not matter when you're working with combinations. The number of combinations of n things taken r at a time is NCR, or sometimes I'll say n choose r. All right, combinations. Order does not matter. Order does not matter. On the calculator, again, we'll use the math button, then highlight PRB, option 3. All right. Combination of 7 things taken 3 at a time, or 7C3. 7, math, probability, option 3. This is 7, choose 3. Is 35. Okay. It's equal to 35. By hand, which I know you're not going to choose to do, and I probably won't as well. By hand, it would be, I start with 3 numbers, 7, 6, 5, and then we have to divide by 3 factorial, which is 3 times 2 times 1. And 3 times 2 in the denominator would divide out with the 6 in the numerator, so we'll be left with 7 times 5, which is 35. I'm not going to do this by hand. You're going to use a calculator for combinations. 10, choose 2, go to the calculator, 10, choose 2. Press the wrong thing again. 10, math, probability, 3, choose 2. is 45. How many different combinations of 5 letters can be chosen from the alphabet? We're looking for combinations, so order does not matter. Right? How many different combinations of 5 letters chosen from the alphabet? Okay, so the alphabet, that's our N, right? And how many letters are in the alphabet? 26. So 26, and we're looking for combinations of 5 letters. So it would be 26, choose 5. Enter that into the calculator, and that results in 65,780. Next, how many different combinations of 3 consonants out of the 21 consonants and 2 vowels out of 5 can be chosen from the alphabet? Okay, so we're looking for combinations of 3 consonants out of 21, and whenever we see and, it's going to be multiply. 2 vowels out of 5 can be chosen from the alphabet. Okay. So we want combinations of 3 out of 21. So from the 21 consonants, we choose 3 times, and we're looking for 2 vowels out of 5. From the 5 vowels, we choose 2. And we would multiply this. So we do 21 choose 3 times 5 choose 2 on the calculator. And that would result in 13,300. And our last example, how many different committees of 6 people can be chosen from a group of 10? All right. The larger number is always your N. So from the 10 people, we're looking for groups or committees of 6. From the 10, we choose 6. And 10 choose 6. Is 210. And this concludes our lesson for today. Thank you.